Welcome to this explainer. Okay, let's dive into this. Because today, we are looking at literally the architect of reality as we know it. I'm talking about Sir Isaac Newton. We're going to unpack the sheer epic scale of his impact on our modern universe. You know, it's almost impossible to overstate just how much of the world around you is running on the exact mathematics this one guy figured out over 3 centuries ago. To really wrap your head around this, just imagine for a second losing all of this stuff. No satellites orbiting above us, no GPS guiding your maps on your phone, no skyscrapers piercing the clouds, no airplanes, no modern engineering whatsoever. It's crazy to think about, but every single one of these modern marvels depends entirely on physical principles discovered by a man working by candlelight in the 1600s. Without his foundational blueprint, the whole technological civilization we live in, it simply vanishes. Section 1. The world before Newton. To truly appreciate the solution he gave us, we first have to understand the mystery of the time. And this brilliantly illustrates the massive paradigm shift that changed human history forever. See, before Newton, humanity relied heavily on philosophy to explain things. We knew that objects felt, right? We knew rain came down, we knew the sun rose, but we completely lacked a unified explanation for why. The universe was just this huge collection of isolated observations. Then, Newton comes along and fundamentally changes the game by proving that nature isn't just some random collection of events. It actually follows strict, unified mathematical laws. He literally dragged our understanding of the universe out of pure philosophy and into the realm of rigorous mathematics. Section 2. The making of a genius. So we gotta ask, where does a mind like this actually come from? Well, his origins were actually unexpectedly humble. Born prematurely in 1642, so tiny they didn't even think he'd survive, actually. And without a father, he had a deeply lonely childhood. But by 1661, he makes his way to Trinity College, Cambridge. And instead of just absorbing the old ideas of Aristotle like everyone else, he starts actively questioning them. But the real pivot, the real game changer, happens in 1665. The Great Plague shuts down Cambridge entirely, forcing Newton to go back home into total isolation. And working largely alone, he enters what historians call his annus mirabilis, or his year of wonders. It was a period of absolute hyper-productivity that birthed ideas that would literally transform science. Now, he wasn't actually considered a child prodigy right off the bat, but he was undeniably obsessed with how things worked. As a kid, he built water wheels, mechanical toys, sundials, you name it. But honestly, more important than what he built was what he asked. He constantly asked, why? That single, simple question, fueled by this incredibly intense, quiet focus, totally set the stage for civilization-changing discoveries. Section 3. Decoding the universe. This is where we get into the massive pillars of his physical discovery. Okay, we have to address the famous myth right away. Did an apple actually fall and hit him square on the head? Well, probably not. The cartoon version of this story we all grew up with is basically a myth. But Newton himself later recounted that simply observing an apple fall in an orchard was the real catalyst. So it wasn't the physical impact on his head that mattered, it was the impact on his mind. And that simple observation led to this incredibly profound question. If the apple falls to Earth, why doesn't the moon? I mean, it sounds so simple to us now, right? But this specific thought was absolutely revolutionary. For the very first time in human history, a single human being connected terrestrial mechanics, things happening here on the dirt, with celestial mechanics, things happening up in the heavens. Which brings us to the law of universal gravitation. Now, what's really interesting about this slide is the word every. Every single object attracts every other object. The sun attracts the planets, the moon attracts the oceans to make our tides, and you attract the Earth just as the Earth attracts you. So you might be wondering, why don't you feel a gravitational pull to the person sitting right next to you? Well, it's simply because your masses are tiny compared to a planet. The force is absolutely there. It's just way too incredibly small to notice. Beyond just gravity, Newton laid out the absolute bedrock foundation of classical mechanics with his 3 laws of motion. Let's break this down. 1. Inertia. Basically, objects just keep doing what they're doing unless they're forced to change. 2. Force equals mass times acceleration, the literal fundamental equation of movement. And 3. For every action, there is an equal and opposite reaction. Boom. To prove why this actually matters to your daily life, just think about these real-world examples. You buckle a seatbelt because of that first law, inertia. Your car accelerates onto the highway because of the second law.
And when you jump up in the air, or when a bird flaps its wings to fly, or heck, when a massive rocket launches into orbit, that is the third law in action. Without that equal and opposite reaction, literally nothing could propel itself forward. Section 4, light, math, and mastery. Because as if cracking the code of gravity and motion wasn't enough for one lifetime, his genius extended into entirely different disciplines.
See, to actually calculate all this complex planetary motion, he needed an entirely new type of math that just didn't exist yet. So what does he do? He just invents calculus. Independently developed by both Newton and Gottfried Wilhelm Leibniz, calculus is the mathematics of change, growth, and motion. And today, the very same calculus he developed is what powers our artificial intelligence, models our global economics, and even allows us to predict the weather. Talk about a legacy. He also got curious and decided to ask, what exactly is light anyway? By passing sunlight through a glass prism, he proved that white light isn't colorless like everyone thought. It's actually a combination of all 7 colors. And because traditional telescopes at the time suffered from this terrible color distortion in their lenses, Newton just went ahead and invented the reflecting telescope to fix it. It was a design so brilliant that nearly every major astronomical observatory today still uses reflecting telescopes based on his general idea. All of this unbelievable genius culminated in 1687 with the publication of the Principia Mathematica. This is widely regarded by historians as one of the most influential scientific books ever written. Inside this masterpiece, he officially unified the heavens and the earth under mathematical physics, definitively proving once and for all that the universe is a predictable, measurable place. Section 5, Newton's everlasting legacy. So, what happens to a man after he basically solves the physical universe? Believe it or not, he actually turns to public service. Following 1687, he became the master of the Royal Mint, where he ruthlessly fought counterfeiters and reformed England's currency with the exact same rigor he applied to physics. He also served as president of the Royal Society for years, and in 1705, Queen Anne knighted him, making him Sir Isaac Newton, largely for his political and public service, not just his staggering scientific achievements. But, he was incredibly human, with some truly quirky traits. He never married, and his intense focus really bordered on obsession. Like, he would regularly just forget to eat while working on a problem for weeks at a time. He also devoted enormous amounts of time to studying theology and alchemy, basically trying to turn lead into gold. While that obviously didn't yield the same physics breakthroughs, it just goes to show a mind completely desperate to uncover all of reality's secrets. He was eventually buried with immense honor in Westminster Abbey. So the crucial point is understanding how his theories hold up today. As science advanced, we found limitations in extreme scenarios. When you get near the speed of light, you need Einstein's relativity. When you look at the microscopic world of atoms, you definitely need quantum mechanics. But here's the thing, Einstein didn't disprove Newton. For everyday speeds, sizes, and real-world engineering, Newton's laws remain extraordinarily accurate. Which is exactly why his work acts as the literal engine of the 21st century. Every single robot programmed to move, every medical imaging device, the physics engines in the video games you play at home, and every rover we send to Mars relies on the equations established by Sir Isaac Newton. Over 3 centuries later, this one man is still actively running our modern civilization. He once famously said, "If I have seen further, it is by standing on the shoulders of giants." And this just perfectly encapsulates the scientific method he helped pioneer, a method relying on observation, measurement, and building upon shared knowledge so the next generation can reach even higher. And that brings us to the end of our explainer today. We've looked at how a single curious mind, just by asking why, literally reshaped human history. I want to leave you with a provocative question to consider. Looking at the sheer scale of his genius, which of Newton's achievements amazes you the most? Is it the laws of motion, universal gravitation, the invention of calculus, or his discoveries about light? Think about it. Keep asking why, and I'll see you in the next explainer.